So if a particle is moving in this direction, it's considered in the positive direction.
So is that when the velocity is positive?
When the velocity is positive. So when it's going back, it's going to be in the negative direction. Excellent. When the velocity is less than 0. So in question part number 4, positive direction. Okay. I don't understand why these pages are not sticking together, so I'm going to just remove them for now. Okay, so then we have t. We are given the interval from 0 to infinity. We have v of t. And we know that the velocity is 0 at 0 and 2. These, we haven't talked about that. I shouldn't mention it. Okay, so the velocity is 0. Here, at 0 and at 2. Now, I think that this problem should really be in the next chapter, but I need to explain something before we continue. So here is a function. Obviously, this function has a local, it's called local or relative. Interchangeably, use the one you like, max. Obviously here, same thing, but min. So let's draw few tangents. Tangent here, tangent here, tangent here, tangent here, tangent here, and then here, and then here, and then here, and then here, and here, and here. So these lines, these tangents, have a positive slope. The tangent here has 0 slope. All these tangents have a negative slope. The tangent here, 0. And all these have positive slope. So what tells us basically is the function is increasing when its derivative, because these tangents are given by the derivative at that point. When the derivative is positive, the function is decreasing when its derivative is negative. And then the function is increasing again when its derivative is positive. So I need, no matter what, I need to study the sign of the derivative. I will plug in, I don't need it in the table, so I'm just going to put it like this. In the velocity, I will plug in 1 and see the number, but I already have it because they asked me to determine it. It's a positive number. To the other side, let's say I will plug in 3. So let's see what we get with 3. This is positive, this is positive. How do I know? Well, 3 minus 2 is positive. This is always positive. We already know. It's always positive. And I put 3 in here, but there is a negative, which means that the velocity is negative past 2 seconds, which tells us that between second 0 and second 2, the particle is moving in the positive direction, and here in negative direction, between 2 and infinity. We can say there is no infinity. I agree, whatever. Past second 2, it will always go in the opposite direction. So it's in a negative direction because the derivative, because we know that this is s prime of t. This is the derivative of the distance. Any questions on this concept? or how we do. Yes?
I think I get it like pretty well, but is the reason we have zero, like zero is our starting point, is just because velocity won't be less than zero because we're not comparing distance less than zero because it doesn't exist?
So we're not talking about the distance. This is the derivative of the distance, which is the velocity. Yes, we can have negative velocity in the sense of direction. I can never say that I'm driving at negative 40 miles an hour. I can say, yes?
Will t, like, not v of t, but would t never be less than zero?
T is time.
Okay.
T is time. So I have to use the domain that is given to me. So in the problem, we have t greater than or equal to 0. There was somebody else, I think Colby wanted to ask something.
Yeah, so I'm just making sure I understand this correctly. The domain comes from the e to the t being, it could only be positive.
No, the domain comes from here.
Oh, okay.
Because I'm specifically told that the time starts with 0 seconds.
And the little graph that you made?
Yes, this is not connected to the problem.
Oh, okay.
This is an explanation about the relationship between the derivative and the function. So I wanted you to understand, because we are going to connect these concepts in the next chapter. So whenever, and also connecting into this, right, these two. So what I'm saying here is this. If the velocity is positive, the distance is increasing. If the velocity is negative, the distance is decreasing. Meaning, I start from home, I go to school. The distance is increasing. I'm coming back. The direction of my speed is negative because I'm decreasing the distance. And at the same time, I'm decreasing the distance. So when I go back, my velocity has direction negative. When I go away, my velocity has direction positive. And this is connected to the distance. So if the derivative is positive, the function, not the derivative, the function is increasing. The distance will be increasing. When the derivative is negative, the distance is decreasing. When the derivative is positive, the distance is increasing again. Anyone else? Is this okay? So again, this was just a connection that we will work on from the next chapter on. But I would like you to understand it now, the connection between the behavior of the function and what happens to the sign of the derivative, or vice versa. The sign of the derivative and the behavior of the function. They go in sync. The behavior of the function dictates the sign of the derivative. The sign of the derivative dictates the behavior of the function.
Also, I have one last question.
Please.
So for, I know it's only asking for the positive direction, but would, like, for 2 to infinity, if it turned around, is it just asking for, like, the small, like, what interval are they asking on? Because how do we know, like, if
so I would say that that between 0 and 2, the particle has a positive direction. Between 2 and infinity, the particle has a negative direction, exactly how I wrote it here. Between 0 and 2, positive direction. Between 2 and infinity, negative direction.
Okay. Okay, thank you.
Well, of course, there is no infinity. They will have to give us something else. 10 seconds, 15 seconds, whatever. Good. Anything else before we continue? Okay. Find the total distance traveled during the first 6 seconds. Okay, so now they are changing, of course, they're changing the infinity into 6. Fine. So, and they want total distance between 0 and 6 seconds. Okay, so here is the diagram that they will ask at some point in time, so I don't have to do it then, I'll do it now. So at time t equals 0, the particle is here. For 2 seconds, second 1, second 2, so t equals 2 seconds here, the particle is going in this direction. It turns, all of a sudden it turns around, and for 4 seconds, right? So this is t equals 6. It goes this way, according to what we just determined. So between t equals 0 and t equals 2, the particle is moving in the positive direction. Between 2 and 6, it goes back. So between t equals 2 and t equals 6, it goes this way. 1, 2, 3, 4 seconds. So that's the diagram. So regardless if I'm going from home to school or back, the odometer will never go back. So I have, let's say, 10 miles between my home and school. So that's 10 miles. It doesn't matter that my direction is negative now. I'm still coming back 10 miles. So the odometer will say the reading will be 20 miles. So my point here is this. We will add these 2 seconds. So the distance, total distance, TD, total distance equals the absolute value of S of 2 minus S of 0, which is this distance. And you can say, but it's positive. You don't need to use the absolute value. True. Plus this distance, which is S of 6 minus S of 2. And this one definitely needs the absolute value because otherwise it will be negative. And I can't. It would be nice if I go from home 10 miles to school, and when I come back, the odometer subtracts 10 miles. It will not. So regardless of which direction I drive to or from, the odometer at the end of the day, if I only go 10 and 10, then it will say an additional 20 miles. So careful here. You may say the absolute value is not needed here. I agree, but it's definitely needed between S of 6 and S of 2. So now I will go to our function, plug the function in the graphing calculator, and determine these values, 0, 2, and 6. So let me share my screen. Calculator, share, here it is. So in y equals, the function was x squared e to negative x. You know me, I love my parentheses. Okay, so second and table, and I want 3 numbers. I want 0, which I know the answer. I don't need the 0, but anyway, and 6. So careful now. The first one, as expected, as we knew. Let me make sure I keep my papers in order. Okay. Okay, I'm on page 4. So then total distance will be the absolute value of S of 2, 0.54. I'm going to use just 2 decimal digits. Minus 0, of course, plus, which we knew from the beginning, it doesn't need the absolute value. S of 6, 0.08. Now I changed my mind. I'm going to use 4 digits. I'm just going to use 4 digits, 5413. Okay, 0.0892 minus, as expected, this will be negative, so it can be 0.5413. Okay, so that's why we need the absolute value. The first one, as you already knew, is definitely doesn't need the absolute value, is 0.5413. But this one, if you subtract these two, you will see you get a negative number, but the distance cannot be negative. So can anyone give me that number? So what is it? 0.0892 minus 0.5413. Lazy people use a calculator for a simple subtraction. So with the absolute value, I have 0.4521. So then I add 0.5413. Okay, and I got 0. No, of course, because he calculated 0.5413 plus 5421. I didn't need any calculator for that. 9934, and the measurement unit was feet. Feet and seconds. Okay. And this is the total distance covered between second 0 and second 6. Yes, I'm ready.
Did you get the number 6 from the problem?
That maybe I read it incorrectly.
No,
Find the total distance traveled during the first. No, it's better to go back and check because sometimes I may look at something else by mistake. So find the total distance traveled during the first 6 seconds.
I wasn't doubting that you had it correct. I just don't have that page pulled up and was trying, and that's where I thought the number came
But
from.
I was doubting because, you know, when a student asks something, I always say, oops, maybe I didn't see something. So I'd rather go back and check. I don't ever take it personally. I always say, oops, maybe I made an error. Ever. So don't ever feel that you shouldn't say something. Always say whatever you think it's, and I always go back and check. Okay, we did look at the diagram, so that's what it is. I'm moving on to find the acceleration at time t, and after 1 second. So what do we do now? So we're skipping over 6 because I already have it here. So 7, we're asked to find the acceleration. How do we proceed?
Is it acceleration the second derivative?
Yes. So is the first derivative of the velocity or the second derivative of the distance? Awesome. 100 pages ago, I had the derivative here. I don't want it factored now. I want this. So I'm going to copy v of t as 2t e to negative t minus t squared e to negative t. No, I don't want to use the product rule. I'd rather use this. Or maybe we should use the product rule because maybe in this case I don't have to use it twice, but that's okay. So a of t, this is a product. So since it's just 2, I'm going to just say 2t prime is 2 e to negative t plus 2t e to negative t times negative 1. So this is only this. But I'll be very careful with this minus. So I'm going to put minus in parentheses. T squared prime, which we already have. This is the first derivative. It's this, but let's write it again. So it's 2t e to negative t and plus t squared e to negative t, exactly what we just had, times negative 1. Okay, then 2e to negative t minus 2t e to negative t minus 2t e to negative t, but plus t squared e to negative t. What a function. Okay, so these are like terms. So 2e to negative t minus 4t e to negative t and plus t squared e to negative t. And I will factor out e to negative t. T squared minus 4t plus 2. This is not factorable, so this is it. So we determined the acceleration, but now they want the acceleration at time 1 second. Let me double check. I think that's what they want. And after 1 second, correct. So 1 plus 2 is 3. 3 minus 4 is negative 1. So this is negative 1 over e. Measurement unit.